That's just a good song. Intro music. It's a good thing. Lesson 1-9, patterns, equations, and graphs. Let's do it. Alright, so sometimes there's equations with two variables in it. How do we know if 310 is a solution to the equation? Well, an ordered pair is always in the order x, y. They're always in alphabetical order. If the equation had a and b in it, then it would go a, b in the ordered pair. They're called an ordered pair because they're in order. Yes, that's right. Okay, so how can we figure this out? Well, we're going to substitute a 10 in for the y and a 3 in for the x. Does 10 equal 4 times 3? Of course not. So, is 310 a solution? No, it's not a solution. How about these? Check these. See if any of these are solutions to y equals 4x. Pause, do it, and then push play. Alrighty, y equals 4x. Remember that it always goes x, y. So 5 is x. So 4 times 5, does that equal 20? Yes! How about here? Y equals 4x. X is negative 5. Y is negative 20. Does negative 20 equal 4 times negative 5? Yes! It does. How about over here? Y equals 4x. X is negative 20. So 4 times negative 20. Y is negative 5. Does negative 5 equal 4 times negative 20? Well, that's negative 80, so no way. How about here? Y equals 4x. X, y. 1.5 is x. So 4 times 1.5 equals 6. Well, what is 4 times 1.5? Oh my heavens, it's 6. So, yes! So that's pretty crazy. There's a bunch of different solutions when there's two variables, huh? Interesting. Alright, so both Carrie and her sister Kim were born on October 25th. How trippy is that? Same birthday, but Kim was born 2 years before Carrie. So Kim's older by 2 years. How can you represent the relationship between Carrie's age and Kim's age in different ways? Well, we know that Kim was born 2 years before Carrie. We need some different ways to represent that relationship. How about in a table, an equation, and a graph? Here's a table. When Carrie is 1 or 2 or 3 or 4, 5, 6, 7, 8, 9, 10, Kim is going to be 2 years older each time. Hey, there's a table. How about an equation? If we let x equal Carrie's age and y equal Kim's age, from the table you can see that y is always 2 greater than x. Or, if you're smarter than this book, you can say that let c equal Carrie's age and k equal Kim's age, and then you get k equals c plus 2. But let's go ahead and see how they have it. Y equals x plus 2. Not quite as cool as k equals c plus 2. Because then we know that k is Kim and c is Carrie. Come on, that's awesome. Alright, draw a graph. Carrie's age down here. Kim's age up here. When Carrie is 0, Kim was 2. When Carrie was 1, Kim was 3. When Carrie was 2, Kim was 4. Always 2 years more, right? When Carrie's 4, Kim is 6. So we're going to plot a bunch of them points and then draw a line through them. Because is it possible for her to be, 6 months old? Yeah. And then Kim would be 2 years and 6 months old. Okay. See if you can figure out number 2. Okay, so Willie is going to run 6 laps before Megan joins him at the track. So I can already tell you one thing. Will's laps equals Megan's laps plus 6. There's one way. How about this? Will, Megan. When Will has run 6 laps, Megan has run 0. When Will has run 7 laps, she will have done 1. When Will has run 8 laps, Megan will have done 2. 9, 3, 10, 4. Over and out. Okay, so I got a table, I got an equation, how about a graph? If I say, here's Will's laps, and over here is Megan's laps. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When Will is at 6, Megan is at 0. So over 6 and up 0. When Will is at 7, Megan is at 1. When Will is at 8, Megan is at 2. Draw a line through them. And then B. Describe how the graph in problem 2 would change if the difference in ages were 5 years instead of 2 years. Well, when Carrie was 0, Kim would have been 5. When Carrie was 1, Kim would have been 6. When Carrie was 2, Kim would have been 7. And it would go on in the same pattern. The line would be the same. Whoa, that was weird. The line would be the same shape, same slope, just a little bit higher. 2 units higher. 2 units higher. And for those of you keeping score at home, the secret code phrase is cotton-headed ninny-muggins. You're not a cotton-headed ninny-muggins. So when you observe a pattern and then make a conclusion based on that, we call that inductive reasoning. The table shows a relationship between the number of blue tiles and the total number of tiles in each figure. When there's 1 blue tile, there's 9 total tiles. When there's 2 blue tiles, there's 18 total tiles. When there's 3 blue tiles, there's 27 total tiles. There's a table that kind of shows that relationship. What's the total number of tiles in a figure with 8 blue tiles? Well, we got a few different methods we can use. We can draw a graph. When there was 1 blue tile, there was 9 total tiles. When there was 2 blue tiles, there was 18, and we could continue this path. Unless we're using graph paper, that's not going to come out real nice. So if you're using graph paper, cool. If you're not using graph paper, maybe you should try something else. How about we write an equation? Y equals 9x. Or if you were super awesome, you might say T for total tiles equals 9 times B for 9 times the number of blue tiles. I don't know. Maybe if you're just like really cool, you would do that. But sometimes your B might look like a 6. So you got to be careful. That's why I type. Okay, so then I would plug in an 8 for x because I want to know if there's 8 blue tiles. 9 times 8 is 72. So the total number of tiles would be 72. Alright, so use the tile figure from problem 3 and see if you can do A and B. Alright, so we need to make a table showing the number of orange tiles and the total number of tiles in each figure. Alright, so when there's, say we're making a table. So, orange tiles, total. When there are 4 orange tiles, there's a total of 9 tiles. When there was, in the second one, we've got 8 orange tiles and 18. Here we got, let's see, we got 4 times 3, which is 12, and then we had 27. So let's see, how many tiles in all will there be in a figure that has 24 orange tiles? Well, let's see. Each time we go up by 4 here, we're going up by 9 here. So if I go up 4 more, I'll have, I'm going to have to continue this over here. Orange total. If I go up 4 more, that would be 16. And then 4 more than that would be 20. And then 4 more than that would be 24. So, 9 more than 27 would be 36. Plus 9 more would be 45. Plus 9 more would be 54. So there would be 54. There would be 54 total tiles in a figure that has 24 orange tiles. So B says make a table showing the number of blue tiles and the number of yellow tiles. So we're going to make a table of blue versus yellow. Alright, so when there is 1 blue, there are 2 yellows. When there are 2 blues, there are 4 yellows. When there are 3 blues, there are 6 yellows. Well, what's the pattern here? There seems to be twice as many, right? So I think that yellow equals 2 times blue. So if I want to find out what happens when there's 24 blue tiles, yellow equals 2 times 24. So there would be 48 yellow tiles. Hey, you're done with 1.9. Go on to those practice problems and then work on your formal write-up. Talk to you soon. Bye-bye.